In the last question, question 3 and 7, you are required to plot the shear diagram and bending moment diagram of this beam. I'm going to do the calculations first. If it is the free body diagram of the beam, we have here, if I name this end A and this end B, here we have RAY and RAX. At this point, we have a concentrated moment of 60 kilonewtons meter, and at this point, another one with a magnitude of 120. And at this point, we just have one RBY. As the last questions, we have sigma fx equals to 0, so RAX is equal to 0. Then I'm going to write the moment equation at point B with this direction marked as positive. So we have RAY times 10, which is this distance, 3 plus 4 plus 3, plus 60 plus 120 equals to 0. So we have RAY equal to minus 18 kilonewtons. And finally, we have sigma fy equals to 0 with this direction as positive. So we have RAY plus RBY equals to 0, and this leads to RBY equals to 18 kilonewtons, and this one is upwards because this one was downwards. So I'm going to plot the free body diagram again. We have minus 18 plus 18 and two moments of 16 and 120 kilonewtons per meter. So based on the sign convention, you can see that the shear of this beam is uniform and it is negative because it is going to make a sad face of the beam. So the shear force here is uniform and equals to minus 18 kilonewtons. And it is negative. And for the bending moment, you can see that at this point and this point we have zero moment because they are all supports, and we have two critical points here and here. I'm gonna write the distances also. So we have two critical points. I'm gonna name them C and D. And here we have A and B. So we have the bending moment 0 at point A, and we're going to calculate the moment at point C. Here M at point C. We just need to first look from the left hand side to point C and then look from the right hand side to point C. From the left hand side, we just have one concentrated force of minus 18, and so at this point it makes a negative bending moment equal to minus 18 times 3. So M at the left side of point C is minus 18 times 3 and equal to minus 54 kilonewtons meter. At the right hand side of the point C, we have both the moment created by this force and this concentrated moment. So we have minus 18 times 3 plus 60, which is equal to 6 kilonewtons meter. So here, from point A to left hand side of point C, we go down to minus 54, and then we jump to 6 for the right hand side. In case of point D, at the left hand side, we have a moment created by this force at this point, you can see. So it is 18 times this distance, which is 7, and you also have to consider this force. So at the left hand side of point D, we have minus 18 times 7 plus 60, which is minus 66 kilonewtons meter. And at the right hand side of point D, you can see from the free body diagram that you have a moment created by this force, and this distance is still 7. You have to consider this concentrated moment as well as this concentrated moment. So the value will be minus 18 times 7 plus 60 plus 120, which is equal to 54 kilonewtons meter. So at point D, left hand side, we have minus 66, and right hand side we have positive 54. So from here we're going to go here, and at point B we also mentioned that bending moment is 0. So this is the bending moment diagram of the beam.